By the end of this video, you will understand AI better than 95% of people out there. And the reason why I'm making this video is very simple. If you are here, chances are that you are consuming content about AI pretty much on a daily basis. Maybe you're reading a news, maybe you're watching a video, maybe you talk about it with a friend. But the problem is that AI is not actually a field that is easy to understand. There is a lot of concepts and complexities behind it. And so in this video, I will try to take some of these concepts that we see all the time in the news, articles, or videos, and really make it super digestible so that you can really understand what's going on in the AI space. Okay, so for this video, I divided the concepts that I want to cover and explain to you into different buckets, into different categories. And the first bucket is actually what AI actually is and is not. And the first term and concept that I want to talk about is AGI, which stands for Artificial General Intelligence. So most people hear AI and think of a robot that can do anything. And that is AGI, it's Artificial General Intelligence. It means that it's a system that can learn and reason like a human across any task. So not just the one it was trained for. So what we have today, and this is important to understand, is not AGI, not even close. We have models that are trained to do specific things like answer questions or generate images or write codes. And they are great at those things, but they are stuck in their lane. But the thing is that they are just good for that. Even if you fine-tune, let's say, GPT-4 to be great at legal analysis, it cannot suddenly perform well at a medical diagnosis unless it was also trained for that thing as well. And so basically what I'm trying to say is that there is no flexible transfer of knowledge in the way humans can do it. And probably another thing that a lot of people miss is the illusion that the intelligence gets stronger as these LLMs becomes better at language. But here the main problem is that the model is not forming goals or planning long-term strategies or building mental models of the world. It's just mapping input to output using statistical correlations from its training data. AGI, and so Artificial General Intelligence, can be reached only when this AI would be able to reflect on its failures, improve without even being retrained, and switch context with no effort. And it would also understand consequences and form intuitions. And trust me, there is nothing like this right now. Now, the other super important concept that I want to cover is actually LLM, which stands for Large Language Model. This is probably a terminology that we use it maybe on a weekly basis. If not more. And so most people using ChatGPT don't actually know what a language model is. And so the basic idea here is that the LLM is a neural network that is trained to predict the next word in a sequence. And that's pretty much it. But when you train it on nearly the entire internet, it gets shockingly good at guessing. And so because it's that good, it feels like it understands you. And so the large part of this acronym, Large Language Model, refers to the scale. And so GPT-4 likely has over 1 trillion parameters. And these are numerical weights that define how the model connects concepts during inference. And so it doesn't really store the knowledge like a database, but it encodes probabilities between tokens. And so the sentence, for example, the capital of France is, leads to Paris, not because he memorized a fact in a traditional sense, but because that token sequence showed up frequently enough in a high confidence context. Now, this obviously gets confusing when we know that ChatGPT now, for example, has the web search capabilities. And so it can literally go on the web and search for facts. But we still have to remember that LLM is something that tries to predict the next word in a sentence instead of taking the knowledge from a database. Now, another super important concept that I want to cover is generative AI. So again, a buzzword that we see everywhere. And this simply means an AI system that produces new content rather than just classifying or analyzing existing input. So that could mean text, images, music, video, code, or even 3D models. Now, when we say generate, what we actually mean here. So this actually means sampling from a probability distribution over possible outputs. And so it's not really kind of a creating from scratch in a human way. When you type a prompt into ChatGPT, it just takes the probability distribution of possible outputs and tokens that it can add to sentences and phrases. And so a key misconception here is that generative doesn't mean original, it's derivative by design. So the outputs are synthetic, but they are shaped entirely by patterns in the training data. And so there is no concept of authorship, and the model doesn't know if what it produced is actually true or useful unless there is a feedback loop created into it, which is obviously the case. And if we want to go a level deeper on this, we have to also understand that generative models like GPT doesn't give you the output in one go. You actually create different tokens that we're gonna explain in just a second, but the output is divided into tokens. And so the model never sees the entire final result at once. It kind of generates outputs one token at a time. And actually, when we are developing with AI, we can tweak what is called the temperature, which simply means tweaking the randomness of the next guess, one word at a time. Now let's jump into the second category of concepts that I want to explain to you, which is how language models work. And so the first concept that I want to explain to you, that again we find very often online, is what is called transformer. So transformer is the architecture that made modern language models possible. Before transformers, models had very short memory and slow training and very limited scalability. And transformers really changed all of that. At the core of the transformer, there is one idea, which is attention. The model doesn't just read a sentence from left to right. It basically learns which words are important in relation to others, regardless of position. For example, if we take the sentence, the city they visited was beautiful, the word they could refer to something several words earlier. And so traditional models will struggle with that, whereas transformers can easily link them using attention weights. And here what people usually don't realize is that transformers process all tokens in parallel and not sequentially, and that's why they are so fast to train and scale across GPUs. And here every major model you heard of, like GPT, BERT, Claude or Gemini, are based on some version of this transformer architecture. Now, terminology that I used already in this video is what is called tokenization. So language model doesn't work with words, they work with tokens, and tokenization is the process of splitting input into these smaller units that the model can process. A token might be a whole word, part of word, or even just characters. For example, the word unhappiness might be split into unhappy and ness. And why this matters? Because every model has a token limit. For example, GPT-4 Turbo has a 128,000 token limit, but that's not 128,000 words. It's more like 100,000 words, depending on how things are split. And so if you copy paste a long document into a prompt, it's the tokens that count against your limit and not just the characters or words. And again, if you want to go a level deeper, you have to understand that there is not one way to tokenize words. Different tokenizers behave differently. And so you have to understand that if you, for example, train a custom model, the tokenizer you use can completely change the output quality. And so here, knowing what's happening at the token level is pretty important. Another concept that you might have heard of is what is called chain of thought prompting. And this is a prompting technique that helps the model perform better on reasoning tasks like math, logical, or multi-step problems. So instead of asking directly for the answer, you tell the model to think step by step. And that phrase matters because literally saying let's think step by step can dramatically improve the output. And the reason for this is that LLMs don't have an internal reasoning chains unless you explicitly prompt them to generate one. Otherwise, they might jump into the most common answer and not the correct one. So for example, if you ask in a prompt, what's the result of 17 times 23? The model can reply 391, and this might be correct or might be a guess. But instead, if you say, what is 17 times 23? And then you add, let's think step by step, then probably the model will do 17 times 20, which is 340. And then we'll do 17 times 3, which is 51. And then they can do 340 plus 51 and then come up to the final response, which is 391. So basically here, you're not teaching the model new math, but you are guiding it to generate intermediate steps so that probability of getting it right increases. By the way, if you've been looking for a way to actually understand AI beyond the headlines and hype, the Oxford Artificial Intelligence program in collaboration with Get Smarter is seriously worth looking into. This is a 6 weeks fully online self-paced course from the University of Oxford, and it's designed not just to teach you what AI is, but to help you think critically about how it works, what it means for society, and how to use it effectively in your business or career. What makes it special? First, the faculty. You're learning from Oxford professors and industry experts who are shaping the future of AI. People like Luciano Floridi, a world-leading expert on digital ethics and philosophy. Michael Woolbridge, professor of computer science at the University of Oxford, and Carl Benedict Frey, who studies how AI is transforming the future of work, and many more subject matter experts. Then there is the curriculum. It covers everything from the fundamentals of machine learning and neural networks to the real-world business applications of AI, and even the ethical, legal, and societal challenges AI presents. Each week is hands-on with real-life case studies, interactive tools, and assignments that help you connect the theory with your own work. And you don't need a technical background. There is no coding required, but you will still walk away with a solid foundation in how this tech actually functions. And once you complete it, you get a certificate from Oxford Said, access to their executive education alumni network, and exclusive resources through edX Career Hub, which includes career coaching, networking events, and even job opportunities. It's a standout program, not just because of the name, but because of the depth, the credibility, and the way it's built for real-world impact. If you've been meaning to level up in understanding AI or just want to future-proof your career, this one is the smarter moves you can make. You can use the code loreox15 for 20% off this course and select Oxford courses on Get Smarter. So if you're interested, make sure to check it out in the video description. Now let's move on to category number 3, which is why AI sometimes gets things wrong. So you probably heard about hallucinations, and maybe you've seen it yourself while using ChatGPT, but basically hallucination is when a large language model generates text that sounds correct but is factually wrong or completely made up. And so the thing here is that this doesn't mean that the model is buggy, it's a side effect of how it works. As we said before, a language model doesn't know facts, it simply generates the next most likely token based on its training data and your prompt. And so if the data was outdated or biased, or maybe the prompt was vague, then the model fills in the blanks using probabilities, and sometimes it doesn't do it correctly. The hallucination, important to understand that it's getting worse in specific cases. So for example, when there is a long form answer, and so obviously here the model has more space to invent things. When there is a very specific prompt, so if you ask for a citation or source and the model hasn't seen it before, it will, instead of telling you that it doesn't know the answer, it will just try to generate an answer, and most likely it's not going to be correct. And we also seen it many times with the code or math, where it basically doesn't give us the logical answer. Another concept that is getting way more popular now is what is called RAG, which is retrieval augmented generation. And this is actually a way to reduce hallucinations. And so instead of you relying on the data that, for example, ChatGPT was trained on, RAG lets it pull real information that you feed to the model. And so what it actually does, you give the system access to a document store or a database, which usually is converted into a vector. And we're also going to cover this concept in just a second. And then when you ask a question, it searches that store for relevant chunks of information. The retrieved text is injected into the prompt, and then the model now generates an answer conditioned on that retrieved content. And so, for example, you can do things like, asking what are your company leave policy, and so the RAG retrieves the HR PDF, finds the page about the leave, and that text gets added to the prompt, and then the model answers based on that, not on guesses. And this obviously makes the system more accurate, more up-to-date, and also more customizable. And a subtle detail here is that RAG doesn't eliminate hallucination, but obviously reduces the chances by adding more context. Now let's move on to category 4 of these AI concepts explained. These are actually concepts that I've been studying recently, and we are going to talk about how data is handled behind the scenes. So the first thing is embeddings. So an embedding is a way to turn data like a sentence or image into a bunch of numbers that capture its meaning. And so instead of comparing text using words, we compare them using vectors, which is simply a list of numbers. And so each vector is like a fingerprint of the meanings. Just to give a practical example, if we say something like I'm happy, maybe the vector could be something like 0.24 and then minus 0.56 and then maybe 0.91 and so on. And then if we go for I feel joyful, the vector will be very, very close to the same vector that I just mentioned. And if I say something like I'm angry, that will be a vector that is very, very far away. And so this allows the system to search by meaning and not just the exact words, and then also cluster similar content together. And that's also the base for very, very powerful recommendations. And so this is where we see the sentence on a website saying, you might also like. And obviously embeddings are not only for text, they also work for code, for images and user behavior in general. Now, the other term that I actually mentioned before is what is called vector databases. So a vector database is built to store and search embeddings quickly and efficiently. And so let's say you have 100,000 documents turned into vectors. Now you ask a question like, what is the refund policy for event tickets? Here you basically want to find the most relevant chunk very fast. And so that's where the vector database comes in. Instead of scanning all vectors, it uses algorithms like the approximate nearest neighbors or other more complex algorithms. And this helps you to find the closest points in space to your query vector, meaning the most relevant result. And popular tools for this are, for example, Pinecone or Chroma. And the common misunderstanding here is that people think that vector database replace SQL. And this is actually not the case, because you use SQL when you need structure. And so, for example, filter all refunds over 200, whereas you use vector search when you want semantic match. And so, for example, find paragraphs that talk about customer complaints. Now, another super interesting concept is what is called knowledge graphs. So a knowledge graph stores information as entities and relationships. And so instead of raw text, it represents facts in structured triples. So for example, Google acquired YouTube, or for example, GPT-4 is a version of LLM. And so these graphs can be huge. You can think of billions of nodes, and they allow models and systems to understand relationships. And so they are used in things like, search engine. So there is a Google knowledge panel that is powered by this. It can be used for enterprise search or even AI reasoning systems. And by the way, these knowledge graphs are not really AI generated. The most high quality graphs are built from structured sources that are maybe curated manually or semi-manually. So there is a lot of engineering behind it. And then the last category that I want to cover with you today is understanding how AI can act. And here again, there is a lot of misconception online, maybe from non-technical people talking about these concepts. And so let's cover first what is an AI workflow. And so an AI workflow is a sequence of defined steps where each one runs a specific task. And usually it's triggered by a condition or input. And so you can think of it like a flowchart or a pipeline. And so an example, let's say that you want to automate email responses to customer complaints. So your workflow might look like this. So maybe there is a new email that arrives, and that's the trigger. Then you use AI to classify the sentiment. Then the third step, if negative, you send to a human. The fourth step, if neutral or positive, then you generate a reply using an LLM. And then the last step is to log the interaction in a CRM. And so each of these steps is very predictable and rule-based, and the logic is very visible. You basically decide what the model should do and when. And this is very popular in business automation. So you can think of tools like Zapier or Make or LangChain. Here the main concept is that a workflow is not trying to figure it out. It follows your blueprint and framework that you built. The other concept is AI agent, which is completely different. An agent has a goal and it figures out the steps itself. So an example could be, you ask the agent, book me a 4-day trip to Italy under $1,500 with good weather. And so you haven't told it how to do that, but an agent might break the task into subtasks. So thinking about flights and then hotels and then weather and budget. And then using tools like APIs or database, decide when it needs to Google or compare prices or ask you follow-up questions, and keep trying until the goal is satisfied or the task fails. And so basically that decision-making loop is what defines an agent. He observes the environment, he plans, he also acts, and also revises the actions. And there are probably two ways of building agents. The first one is called react, which is reasoning and then acting per step. Or there is the other option, which is plan execute, which is planning all steps first and then running them. And so here the point is that agents are more autonomous, but also harder to control. Obviously, things get more interesting when we're talking about hybrids approach. And so one example here is that you have a lead generation workflow, but one of the steps is research the lead's LinkedIn profile and write a personalized message. And so that step could be powered by an agent that navigates the web, extracts the information, and crafts a custom pitch. You basically get the reliability of workflows with the reasoning power of agents, but only when needed. And so this is the direction that most serious AI teams are moving in, because it balances control but also autonomy. And there you have it, a very simple video on most of AI terminologies and concepts that we see pretty much on a daily, weekly basis, explained in a very, very digestible and easy way. As always, if you found at least one useful information in this video, make sure to subscribe to my channel so that I can help you even further in the next videos. And if you're new to the channel, you should also know that I try to help people getting into the data and AI space as a career. And so if you're interested, make sure to check out this video here, where I talk about a complete roadmap that you can follow to get into data. And well, enjoy the rest of your day. Ciao for now, and see you in the next one.